Hello, this is Mr. Greisman, and in this vodcast, we're going to introduce and begin our study of chemistry. Before we do that, though, I'd like to just spend a couple of minutes discussing the previous 2 weeks. Mr. Key and I, in developing this course, realized that because this is a whole different way of learning for most of you, that we needed to get all of us on the same page, as it were. And what we mean by that is that the thing that's really most important to us is that you as students are able to work collaboratively with others. And this is probably something that is unfamiliar to most of you, as it was to Mr. Key and I when we began changing this course. Having spent the last couple of weeks doing these introductory exercises, our hope is that by doing these exercises, you have a better sense of what the course is going to be about in terms of how we're going to be approaching the course, and that you've had opportunities to work with others collaboratively and hopefully see the benefit of not only sharing information but also sharing expertise, both from the person who is the expert and the one receiving the expertise. We hope that these last 2 weeks have been beneficial for you in preparing you for what we're about to undertake. So let's get started. So what is chemistry? Well, chemistry is everywhere and it is part of everything. In fact, it's probably fair to say, what in the world isn't chemistry? So chemistry really is just a way of looking at the world from the perspective of something called matter. So we study matter, and yes, it does. So what's matter? Well, matter is, as you recall from maybe something you learned about in grade 9 or 10, is anything that has mass and takes up space. So it's the stuff in our world that makes up our world. And what we want to look at is how this stuff behaves, how it interacts with other things. And that's what we're going to be spending this semester looking much more closely at. So chemists study the properties of matter and the changes that they undergo. So that means that chemists look more specifically at what this stuff is, how it behaves when it's interacting with other things, and looking at this from a qualitative, that is from your observational perspective, and also from a quantitative, that is from a mathematical perspective. So if we're going to look at matter, what we need to do is we need to be clear about what matter is and how it's classified. So there are two ways to classify matter: either pure substances or mixtures. And if we're looking at pure substances, what we're talking about are things like that picture on the left-hand side of your screen, which is a pile of carbon, and that pile of white stuff is sodium chloride. So a pure substance means that that no matter how big your sample size or how small your sample size is, all the particles will be exactly the same, and they'll all exhibit exactly the same properties. We contrast that, though, with mixtures. Mixtures really are two or more pure substances combined. And then when you look at mixtures a little bit more specifically, you can divide mixtures up into either heterogeneous mixtures or homogeneous mixtures. And the picture on the left shows you a heterogeneous mixture. The picture on the right shows you a homogeneous mixture. And you can notice that there are differences between them. The primary difference is that with a heterogeneous mixture, there are two or more what are called visible components or visible phases. And what that really means is that the two phases or the two components don't ever mix. And you can see that in the diagram, what you've basically got is oil and water, with the oil sitting on top and the water sitting below. And we'll learn more in this course about why it is those things don't mingle. A homogeneous mixture, though, is different because it really only has one visible component. And we call these solutions. We're going to spend a lot of time in this course looking at solution chemistry. So no matter how large your solution sample is or how small your solution sample is, it'll always exhibit the same properties. So again, matter is classified as either pure substances or mixtures. Okay. Let's look at how matter, the states that matter exists in. Well, as you may recall, there are three states of matter. either the gaseous state, the liquid state, or the solid state. And you can see from the diagram how these states are different in terms of how the particles align themselves or exist in containers. So if we look at a gas, for example, a gas will occupy the volume and the shape of the container that it's in. So it doesn't matter how much gas there is, and it doesn't matter how big the container is, the gas will always fill up the container. Okay. We will contrast that though with a liquid. A liquid will occupy the shape of the container, but it has a fixed volume. And you can see from the diagram that the gaseous particles are further apart than the liquid particles. Now, contrast that with a solid, and a solid has a fixed shape and a fixed volume, which means that it doesn't matter how big the container is. If you put the solid into the container, it's not going to change shape. It's not going to occupy any more volume than the volume that it's made up of. In this course, we're going to show you a demonstration that'll contrast a vapor and a gas and the differences between them. So it's important that you're able to distinguish between vapors and gases. If we're going to talk about chemicals, we need to have some ways of describing chemicals, and we call these their physical properties. And these are ways that we either observe with our 5 senses or we measure, and they're characteristics of each individual chemical. So you can see in the picture we have a kilogram of gold. We can describe it in terms of its color. We would say that it would be gold. We can describe it in terms of its luster. We would say that it would be shiny. We could describe it in terms of its solubility. Would it be able to dissolve? Would it not be able to dissolve? What kind of smell does it give off? How hard is this metal? Another way that we could describe it is in terms of its density. That is a measure of its mass per unit volume that it occupies. Then we could ask the question, can this stuff conduct electricity? So we would hook up a battery source or some kind of electrical source and see whether electricity could conduct. There are some physical properties which we can measure. We can actually put specific numbers to them, and that would be, for example, its melting point or its boiling point. So physical properties really are ways that we use to describe chemicals in terms of our observations or in terms of measurement. If we're talking about physical change, what we're really looking at is keeping the substance the same. So we're changing a substance in terms of its state, but we're not really changing its chemical composition. So we're looking specifically just at changes of state. And if we're looking at changes of state, if we're going from a solid to a liquid, we would call that melting. If we were going from a liquid to a gas, we would call that evaporation. And if we were going from a gas to a liquid, we would call that condensation. And if we're going from a liquid to a solid, we would call that freezing. Now sometimes, for like the example of dried ice is carbon dioxide that's been lowered to its to the temperature at which it exists as a solid. Dry ice will go from a solid to a gas. So when something goes from a solid to a gas or from a gas to a solid, we call that sublimation. So let's look at the chemical properties. The chemical properties are the observed properties of a substance as it undergoes a change in chemical composition. So what does that mean? It means that if we take, for example, a piece of wood and we want to see, will this burn? Well, what does that mean? Will it combust? Will it react with oxygen? Well, you can see on the picture on the right that it reacts and can react very violently depending on the type of wood that you're using and how much you've got. So if we look at the picture on the left of the screen, you're seeing in that instance a piece of metal that's been immersed in water, and it undergoes a chemical reaction. So we ask the questions, do these things react with water, with acid, with oxygen, and see whether or not the chemical will, and if it does, we can use that to use it to be a chemical property of that substance. If we're talking about chemical changes, we contrast these with the physical changes that we've described earlier, because a chemical change is a change that alters the chemical composition of a substance. What does that mean? It means that once a chemical change occurs, you can't undo that change. So if you look at the diagram of the car, you'll see that the car is rusting. Rusting is a chemical change. That means that the steel is reacting with the oxygen in the air and changing to, in this case, iron oxide. And you cannot reverse that. You might be able to slow it down, but you can't reverse it. The picture at the bottom left shows you some delicious baked goods. Those baked goods occur because of chemical reactions with all the different ingredients, and they also can't be unbaked. And the last one would be the chemical reaction you see on the right with the flame, which is the burning of methane gas, which is how many of your houses are heated. And we call that a combustion reaction. It's a chemical change because the gas reacts with oxygen and produces carbon dioxide and water, and you can't reverse that reaction. So chemical changes, there are certain characteristics of chemical changes, whether or not it's the emission of light, whether or not it's the emission of sound or smells or heat, some kind of energy or a color change. These are all indications that a chemical change has occurred. They're irreversible. Now that we've had an opportunity to look more closely at chemical and physical properties and chemical and physical change, I'm going to leave you with a question to ponder. And that is, what is higher, the melting or the freezing point of water? Thanks for watching.